In this video, we will discuss about ring. Okay, so the definition of ring. We define as let R be a non-empty set and let two binary operations two binary operations plus, that is addition, and into, that is multiplication, on R follow the postulates follow the postulates first. R under addition is an abelian group. So group हमने स्टडी किया ये. So the condition of abelian group will be, first is closure. So for closure property, that means let A and B belongs to R, which implies that A plus B is also belongs to R. So under addition, that means R is an abelian group. So first closure, second we have associative. So we have three elements A, B, C belongs to R. So then A plus B plus C is equal to A plus B plus C. Third property, identity. So we write down the existence of identity. So existence of identity, that is 0 belongs to R such that A plus 0 is equal to 0 plus A is equal to A. For every A is also belongs to R. So then 0 is the additive identity. So if 0 is present in set R, so we can say that R is satisfy the identity. Now fourth, existence of inverse. So for existence of inverse, let A be the element of R, A belongs to R. So then there exists minus A is also belongs to R. So such that A plus minus A is equal to minus A plus A is equal to 0. So gives us identity. So it means minus A is the additive inverse. Minus A is the additive inverse of A. So then inverse is satisfied. Fifth property, we have a commutative. So commutative property, so we can consider two elements, A, B belongs to R. So A plus B is equal to B plus A. So if we satisfy all five property for a set R, so then R is said to be an abelian group under addition. So R under addition is an abelian group. Now, so this is our first part. We move to the second part. We denoted that part is B. B. So we write down as R under multiplication. R under multiplication is सेमी ग्रुप. तो सेमी ग्रुप के लिए कंडीशन पता होंगे आपको. सेमी ग्रुप के लिए कौन कौन सी कंडीशन सेटिस्फाई करनी चाहिए. वन इज क्लोजर और सेकंड इज एसोसिएटिव. So first condition for this closure property. First property is closure property. So for closure property, let A B belongs to R, which implies that A into B is also belongs to R. So this is the closure property under multiplication. Second is associative property. So associative. So we assume that let A B C belongs to R. So A into B into C is equal to A into B into C. So here we satisfy two property under multiplication, that is semi-group, closure property and associative property. Now we move to the third part, that is C part. So R is distributive. R is distributive. R is distributive. So here we consider both the distributive property, left distributive and right distributive. So we remember the thing, multiplication is always distributive with respect to addition. Multiplication is distributive with respect to addition. Here we can write down multiplication is distributed with respect to addition. अब कैसे ये होता है, we will discuss. So first, left distributive. So there are two distributive means left distributive. Left distributive. अब लेफ्ट डिस्ट्रीब्यूटिव के लिए तो वी टेक फॉर एवरी ए बी सी बिलोंग्स टू आर. सो देन ए इंटू बी प्लस सी is equal to a into b plus a into c. So this is called left distributive. Left, we have taken a in left side into multiplication. So this is called multiplication is distributive with respect to addition. So in bracket we have considered the addition. So second, right distributive. Right distributive. For right distributive, we take element in this way, a plus b into c. This is called a into c plus b into c. So this is called a right distributive. For every a, b, c belongs to R. So if any set, non-empty set, which follow all three sections, means total 9 properties, so then R under addition and multiplication. Under addition and multiplication is said to be a ring. Said to be a ring. फॉर एग्जाम्पल, अब हम एग्जाम्पल लेते हैं कि बेसिक एग्जाम्पल क्या हो सकता है. बेसिक एग्जाम्पल वी कैन कंसिडर इफ वी कंसिडर आर इज इक्वल टू जीरो. आर इक्वल टू जीरो. सो दिस इज द zero ring basically. So R is a zero ring. Zero ring. अब कैसे जीरो रिंग कहेंगे, तो मीन्स हमारा जो बेसिक प्रॉपर्टी दैट इज आइडेंटिटी. अंडर एडिशन आइडेंटिटी इज जीरो. So identity exists and we can satisfy all the properties. So this R is called the zero ring. Now we move to the further definitions of ring. So further definitions, one is ring with unity. So next definition is ring with unity. अब ring with unity, unity means one. अगर आइडेंटिटी एलिमेंट वन, मल्टीप्लिकेटिव आइडेंटिटी वन एग्जिस्ट कर रहा है किसी भी सेट आर में, मीन्स रिंग आर में, So that is called ring with unity. So if a ring has multiplicative identity, has the multiplicative identity 1, so then it is called a ring with unity. It is called a ring with unity. Means any set R which contain identity element 1 and satisfy all the properties of ring and contain 1 also, that is called ring with unity. Now we move to the next definition, that is commutative ring. A commutative ring, it means which satisfy commutative law under multiplication. So if a ring R satisfy the commutative property, अंडर मल्टीप्लीकेशन, एडिशन तो सेटिस्फाई करती है क्योंकि अंडर एडिशन अबेलियन ग्रुप होना चाहिए, तो अंडर मल्टीप्लीकेशन भी सेटिस्फाई कर रहा है कॉम्पिटिटिव प्रॉपर्टी को, मींस a into b is equal to b into a, so then R is said to be commutative ring. For every a b belongs to R, so then R is said to be commutative ring. R is said to be commutative ring. Now, after understanding the commutative ring, we move to the next definition, that is ring with or without zero divisor. With or without zero divisors. So basically we understand both the definitions, that means without zero divisor or with zero divisors. So now we write down a let R be a ring, R be a ring, and A not equal to 0, B not equal to 0, which implies that AB not equal to 0. Or if AB is equal to 0, which implies that either A not equal to 0 or B not equal to 0. So then R is said to be a ring without zero divisor. Without zero divisor. Second, with zero divisor. With zero divisor means this is for without zero divisor, and for with zero divisor, if A not equal to 0, B not equal to 0, which implies that AB equal to 0. The product of two non-zero element is equal to 0. So then it is called ring with zero divisors. With zero divisors. So ring with zero divisors. So when we take the examples related to that, so in matrix, sometimes we take two non-zero matrices are there, A not equal to 0, B not equal to 0, but product is 0. But vice versa, this is not possible when AB equal to 0. So in matrices, suppose we consider A matrix and B matrix. So maybe when we do the product of A and B, so when we consider 2 by 2 matrix here, and here we also consider 2 by 2 matrix. So when we do the product of this, so this product is 0 matrix of order 2 by 2. But BA, it is not possible because BA is also equal to 0. So this is not possible. Okay. In multiplication of two matrices, AB is not equal to BA. AB is not equal to BA.